in your matrix, you can have a data with a key reference 1,1, which means that the value, say value 3 is on row 1, column 1. You could also have another one on key value pair 3,4, which shows that it's on row 3, column 4. So that's what the matrix is like, and I'm sure we've done things like matrices in school at one point or the other. So it's two-dimensional. It has x and y, while vectors have just probably x. Then we have lists. Lists are used for higher dimensional data. For example, you want to have a long a column showing say 1,000 entries. Lists are very good for that, and then it also helps you. You can also input any type of object into your list. So you can input any type of object into your list. List is not restrictive. While data frames are like an advanced version of lists. So data frames are the ones that we probably mostly would use in our analysis. Data frames are data in form of spreadsheets. So your data in your Excel sheet is like a data frame because it has different columns. It has probably the customer ID, product ID, sales, and so on. So that's what data frames are like. And then most of the time, for your analysis, you would have to enter your data into a data frame to be able to perform good analysis on it. So data frames are what we generally use. All right, so let me move on. I'll ask, if you have any questions later, I would ask, so you'll be able to ask your questions. So let me just move on. So we have creating subsets of data. Now for this, we have three types of, 3 ways to create subsets of our data. We have using the $sign, we have using double brackets, and using the single bracket. So we'll be doing all of this in practical, and you'll be able to see how they are used. Reading them now wouldn't make much sense because it's better to see, sorry, I want to see the people that are online. Okay, thank you, Emmanuel. I almost forgot. I was supposed to record. Let me confirm. Okay, everyone is online. Okay, so if I do this now, you probably not understand properly. So in our practical session, we'll be able to understand how to subset data using these different methods. So just move on. I don't want to waste too much time. There's also the sample function. You see it in our practice, and so on and so forth. I'm trying to look at the theory parts. I don't plan to teach us this in theory. I want us to actually do this in our lab sessions. You can also go through this in your textbook. All of these things are in the textbook. This is like a summary of what's in your textbook. So if you read through your textbook, you'll see all of these things that are mentioned here. So it's just like a mini summary of what is written in your textbook. So I prefer us not to read this out because this would be a wastage of time. The best thing would be to do the lab sessions and practice these functions in the lab sessions. So anything, I'm looking for the theory parts of this, so I'll explain them. But wherever there is practical like this, I'll probably not touch it. So I'm going to move on, redeem function, with function, so on. So, okay. All right, with function. Okay, creating subgroups of bins of data. So we all know what the histogram does. For these functions, please, you can read them up and look at their uses, but we're going to be using some of them in our practical sessions. So from our practical sessions, you'll be able to get an understanding of how these functions are used. But I wouldn't want to be reading them out. It wouldn't make much sense to read them out on a slide because practice makes perfect. So it's better to practice them in the lab sessions. So okay, so we all know what a histogram is, and a histogram is usually used to categorize your data into bins. So as you can see, they are categorized into equal bins, and this shows a normal distribution of your data. So most times statisticians, when they want to see what their data looks like, they draw a histogram of their data. So it shows them if their data is normalized or skewed to the left or skewed to the right. So histogram gives frequency. So for 3, we have this frequency, say, I don't know what is here, but it should be middle of 15 and 30. That's about 20 something. So, and so on. So that's what a histogram does. And we have a cut function which helps us categorize our data into bins. That we're going to do in the practical session too. So, okay, this is an example of using the cut function. All of these things are in your manual. Don't be too lazy to read them. This is another example of using the cut function. Then we have combing and merging data sets. So you can comb and merge data sets. You can merge data sets if you use SQL or you are familiar with joining in SQL. You would understand what I'm about to say. But if you are not, just follow along. So in SQL, you do left join, right join, outer join, left outer join, and so on and so forth. So that's what the merge function does. So we have the cbind. Cbind helps you add columns from another data. For example, you can see this place. So say this was your data X, and you wanted to add columns from data Y. So it adds it to the side. That's what cbind does. While rowbind appends your data. It appends rows from another data to your say data X. So if you have data X and you want to append rows from Y to data X, you use the rowbind function, which is rbind. So, and you use rbind when your data sets have the same number of columns. So you can't merge a data set to, for example, say this one has 2 columns and you want to merge a data set that has 5 columns. That wouldn't work. So they have to have the same number of columns. Same thing with this. They have to have the same number of rows to be able to merge them properly. Because if you merge something that is longer, it will probably not work. And even if it does, it would have more rows than this. So meaning that you have misplaced rows. So that would be a problem. Of rows, same number of columns to perform good merging on your data. While this merges as left outer join, right outer join, and so on. So this is used for when it's even useful when data sets don't have the same number of rows. So it just merges similar data sets. So it merges data sets based on, say, a row number or a row name. So say data X has customer ID, data Y has customer ID. It merges your data based on the customer ID that is common to the both data sets. So that is what merge function does. And we're going to see an example in the practical session. Okay, before I move into the next slide, any question, please? Any question, anyone? Before I move into the next slide. Any questions? Any comments? Am I okay? I might not be very clear, but can you hear what I'm saying? And do you have any questions?
Hear what you're saying clearly, actually.
Okay, and there are no questions. Okay, all right, cool. So, moving into the next slide then, since there are no questions. So next slide. All right. So, we can also use lookup tables. You can also work with lookup tables while merging your data. So you can say, or let me say, you can check to see if you have matches in 2 data sets before you start performing merging on them. So how do you check that a data X can be merged with a data Y? How do you check that it is okay to merge them together? How do you check? So let's say in a particular data column code state, or let me say data code states rather, sorry, in a particular data code state and another particular data large state, we have column name and column name in code state, and we have column name in large states. You might not understand everything that's going on here, but just follow me. You have column name in code state, you have column name in large state. Now you want to see that you can perform a merge on code state and large states. You want to be sure that there are some columns and there are some rows in name and there are some rows in large states that are similar to one another. So for example, let's put it in a practical context. If code states contain states that are really cold, maybe they usually have the highest number of raining seasons, in raining times or raining days in the year, and large states are states that are above 100,000 kilometer wide, or kilometer generally. So you want to see the cold states that are also large states, or the large states that are also cold states. So how do you know that there are some cold states that are large states? That means you have to do a merging, and that merging is what will tell you that, okay, rows 1, 2, 3, or names 1, 2, 3 is also present in large states. There are also rows 1, 2, 3 in large states, which means that rows 1, 2, 3 are cold states and at the same time large states. So that is what is called finding a match. So this result now from this one, which we might not properly understand at the moment, but this result tells us that rows 1, 4, 5, 6 are cold states and large states at the same time, while the others are not. So these other ones are not okay. So these other ones are not present in. These other ones are just large states. They are not cold states. So match does it from the back, like it checks it from the back. So it checks that, okay, which large states are cold states. So it reads the command from the back. We have another function that is percentage in percentage. That one reads it from the front. So match tells you that. Let me confirm that. Okay, so it checks that this is similar to this. That's the way match checks. So it checks that there are rows in this that are similar to rows in this. So it means that all these ones with any don't have rows that are similar to, don't have rows in cold states that are similar to those in large states. That's what it checks. But 1, 4, 5, 6 shows us that rows 1, 4, 5, 6 in large states are also present as cold states. So that's what match does. While percentage in percentage is another kind of function, it reads it forward. This reads it backward. This checks large states that are also cold states. So that's what match does. We'll do a practical session, and in the practical session you would understand better. I hope we do something on match in the practical session, because practical session it's just going to give us a scenario. It's going to paint a scenario for us, like we're working for a kind of company and we want to perform some analysis for them. So that's what the practical session is going to be about. But let me just move on and explain it on the surface here. So this I'm also going to check this. This is when you are adding data from a data frame into another one. So I said the data frame is like your Excel spreadsheet. So your Excel spreadsheet contains maybe your Excel spreadsheet X contains some data, and your Excel spreadsheet Y contains some data, and you want to merge some columns, or you want to order some columns or sort some columns based on some other columns. You use this additional sign, and I prefer us to do this in practical session. There is no way I would explain this without doing the practical session. So let's just move on from this. Like I said, let's do this in practical session. Same with this. I'm just looking for the theory parts of this. Okay, so let's look at this. This is theory. So traversing data, you use apply functions to traverse data. So apply functions, they help you to apply a function repeatedly over the elements of a list. So you have some elements in a list and you want to iterate. I'm sure that some of you that probably have an idea of programming, you understand what I mean by iterating. So you want to do a looping. You want it to probably check for a particular thing in your list. So it goes from up all the way down, then it comes back to up and goes all the way down, and on and on and on. So it's going in a loop, like a circle. That is what apply function does. So instead of using for this in this, like you do in programming, you can just use apply functions, and apply functions help you go in a loop. So it helps you perform a function over a list several times until the function is completed, or until the process is completed. So that's what apply functions does. So apply functions are very useful, and it's usually called functional programming instead of the normal imperative programming. The normal imperative programming that we do is using the for loops and all to loop over our functions, and it requires us writing a lot of code. But the apply functions, with few arguments passed into the apply function, you can easily loop over your list. So apply functions are very useful, and it reduces the amount of code you have to write. So these are the arguments it takes in, and you'll see that in the practicals. So we have different types of the apply function. We have the L apply, the S apply, and the T apply. So we would practice these two. Okay. So this is also the formula interface. So on the formula interface, there are some operators you can use to perform some functions. For example, this operator tells you that you are modeling y as a function of x. So y is a function of x. The addition operator tells you to include, for example, say you have this kind of example. It's asking you that you should include columns A, and you should also include columns B. There's this other operator, which is the minus sign. So this formula interface, it does not work as a mathematical symbol. It works as a statistical operator instead of a mathematical symbol. You can see here. It's important to keep in mind that it's important. Please give me 1 minute. Let me stop this call. 1 minute, please.
Ma'am, I think your mic is muted.
Yeah, I muted myself. I thought to give me a minute. Can you hear me now?
Yes, I can.
Okay.
Yeah.
So I'm back. Okay. So on the formula interface, you are using the operators as statistical operators. Yes, not mathematical operators. So your normal additional sign would not add your values together. It would work on columns, and it will help you check that, okay, I want you to include, for example, say this example is telling us to include B and also include A. This is telling us to include A but exclude B, right? This one is a column, not a semicolon, a column, and it's telling us that we should check the interaction of A and B. We should see how well correlated they are, or the interaction between the two of them. This is telling us to include columns as well as their interaction. And you can see what it's saying here. It's telling you that A plus B plus A interacting with B. So include A, include B, and include the interaction of A and B. So that's what this is telling us. We're going to do it in practical. Then this is telling us to estimate Y as a function of a conditional on B. So check Y as a function of A conditional on B. So A conditional B. If you remember conditional statements in school, maybe if you did maths, you will know that you can do A as a condition of something or B as a condition of something, and so on. So this is checking Y as a function of A conditional on B. We'll see that applications of that. Next. Okay, so reshape package. So reshape is a package, and I've told you how you can load packages with library. You can install packages with this. I taught you that some weeks ago. All right, so let's just move into practical. Any question before I move on? You might not have so much of questions because I skipped a lot of things. But any questions or comments? So we're using the my network. It's going to be back now. Just a minute. We are using our virtual environment. So let's open our R Studio. Okay. Are we good? Can we move on? Can we continue?
Yes, Marika.
Yes, we can.
Okay. So I'm going to be working on. Okay. Last week, did you work on the source or the console on
Worked
Friday?
on source. Worked on
You
source.
worked on source. Okay, cool. So that means you know how to use the source now, right?
Yes,
To
Prof.
some extent, yes.
Okay. So um let's open a new source. All right. So from our manual, we're going to be working from our manual. So I'm going to be reading it out, but then it will be good if you have your manual to with you. So I'm on page 108. So you can open to page 108 to follow along. So I'm on page 108, and I'm going to be doing the lab sessions one after the other. So these lab sessions will cover all these functions that I probably skipped, and some of them that I talked about, and some of them that I didn't even mention at all. So let's open to page 108 of our manual. If you have your manual, let me see your hand. If you have your manual with you, let me see your hand. Like, just raise your hand if you have your manual with you.
I can't
One.
raise my hand, but I can have my
Okay.
manual.
Okay, that's two. Anybody else? Let me know. Let me know that you can't raise your hand, but you
William.
have your manual. Okay.
I can't raise my
I
hand
can.
also.
Okay, three, four. Who else? Anybody else? Nobody else. Okay, so no problem. For those that do not have it, I'll just read it out while we work on it. Okay, so performing join operations on a data set. That's lab one. So they're telling us that a big data analyst, Stephen Headley, works with a data analytics company. He has been assigned the task of devising trends of customer preferences for a toaster developed by a company named Popular Electronics. This analysis will help Popular Electronics decide whether the production meets the market demand or not. Popular Electronics provides Stephen with personal and purchase information of its customers in a particular month. Stephen uses R to enter and combine both types of information to find any kind of relation or pattern in the buying tendency of the customers. This lab shows the sequence of steps that Stephen followed to combine the two data sets. So Stephen works in a data analytics company, and he was assigned the task of devising trends of customer preferences for a toaster. So Stephen wants to know what customer prefers, what the customers prefer for a particular toaster developed by a company, and the name of the company is Popular Electronics. So and this analysis that Stephen is going to do will help Popular Electronics decide whether the production meets the market demand or it does not. Now, Popular Electronics now provided Stephen with personal and purchase information of his customers for a month. So Stephen has information for a month, and then he wants to perform analysis on it. He wants to see if there is any kind of relation in the buying tendency of customers. He wants to see how customers buy products. So this is the this lab. In this lab, I'm going to see how Stephen was able to combine the two data sets. So so we have the data sets that were provided to Stephen are customer personal information and purchase information of customers, right? So for this lab, we're going to be doing a lot of join operations. We're going to be doing a lot of joining because we want to join two data sets together. We want to combine two data sets together. So we would probably use inner join, outer join, cross join, and so on. So let's go into the solution. So the solution is on page 113. So we're going to follow the solution on page 113. So now, the first thing we're going to do here is we're going to create the two data frames. So if you see the data on page 108, there's a data there. For those of you that don't have the lab, don't worry, we're going to create the data here, the data set here. So for those of you that do not have the lab book, you just follow my screen. You'll be able to follow along. But now the first thing we're going to do, the first step we're going to perform is we're going to create 2 data frames. And the 2 data frames are going to be the customer's personal information and the purchase information of each customer. So we have the customer's information, their personal information, and the purchase information. So here, now we're creating the 2 data frames. So we have purchase info, data.frame. So when you want to create tables, columns in tables that look like Excel sheets, you use data.frame, which is data frame. So you're creating a data frame. So we have the customer table. We have the purchase table. So we're creating the purchase table first. So the purchase table, we have a customer ID. This lab session will help you learn even faster than reading textbook. But then it will still be very good for you to read the textbook. So we have customer ID to be 1 to 6, and I've explained that we can create this is a vector. A vector is a one-dimensional object. So what we just did now, we created a vector C 1 to 6. So it reads 1, 2, 3, 4, 5, 6. And then we have products. This is a range of numbers. I explained that in the previous class, and I think about 2 classes ago. And then the products too, we have toaster. I want to be sure that I'm following what is being said here. Last class 3. Anybody? Please don't tell me you don't know. I explained in the last class, so I want someone to tell me what's the REP command used for?
To repeat function. To repeat
Repeat function.
a variable. Sorry. To repeat
Okay.
a variable. Yeah. So repeat toaster 3 times.
Class. So 3, and then here. So we've created this data frame. So let's run it. Okay, I have to. Oh, my R is still showing my answers twice. Emmanuel, are you there? Let me see. Maybe Emmanuel will help me. Sorry. I didn't mean to open that. Emmanuel, are you there? Emmanuel is very good with technical stuff. Emmanuel. Okay, Emmanuel is not there. Okay, so I want him to help me check out why my R brings out my answers twice. But for now, just manage it. It's not going to affect anything. It's still bringing out the answers. So purchase info. Let's check what is present in purchase info. So you have purchase.
Please, can anyone hear me?
Yes,
So
I can hear you.
let's create their personal.
I think our network is breaking.
My network is not breaking. I'm here. Can you hear? Can you hear me?
Yes, ma'am. Please go on.
Okay. So I'm here, please. So I just wanted to follow along. I'm typing. That's why I stopped talking. don't worry, I'll try to continue talking. So I'm still here. So data.frame. Then we are creating some columns for the personal information, and we are creating the customer ID column and the state. So the customer ID column has 246 in it. So customer ID equal to, who can tell me the repeat function for creating a sequence of values and skipping it by, say, 2? You want to create a sequence of values and you want to skip it by maybe 2, 2, 2. What's the function used? Anybody?
SEQ, sorry.
SEQ.
Can anyone remember?
Yes, you just said it now. SEQ. Now we can SEQ into bracket 2. Since you want to do 246, it's bracket 2 colon 6 comma, sorry, 2 comma 6 comma 2. I'm really saying colon instead. Sorry, that's it.
Okay, I remember I thought I explained the one for repeating the function twice, but for skipping it out, I don't think I did that. Okay, let's leave that for now. Maybe we've not gotten to that part, so let me just leave that for now. So I remember I talked about the repeating twice, and so on. So let's leave that for now. So let me go back to close my textbook. Repeat function. Okay, so customer ID C 246 and state. Want to repeat states twice. Alabama. Want to repeat Alabama twice. And we want to write Ohio just one time. Oh, sorry about that. Ohio. Oh wow. Just once. Okay. So let's make sure we run this. Control Enter to run it. Then personal info. To be sure we've created it. Personal info. Yep. So here we have customer ID and state. This is not supposed to show twice. Sorry. I don't know what is wrong with my ID. So this is it. Customer ID and state. So we have 246 and we have the state. So that's our customers' information, our customers' personal information. So we've seen what our data is like, and now we want to join our data together. So to join a data together, normally you use the merge function, and it just joins your data frame 1 to your data frame 2, and we have 2 data frames. We have purchase info and we have personal info. So it will join them together, and the kind of joining it does when you don't specify the type of join you want to do is the inner join. So the inner join selects only matching rows in both data frames. So we're going to use merge function. So the merge function purchase info personal info and join them by, so you're telling them to join them by customer ID. So by is the argument for the Why are we joining on customer ID? Why I want to join on anything else?
Because they are both common to that customer
Anybody?
ID is common to both tables. Because customer ID is common to both tables.
No one. Okay. So we're joining on customer ID because customer ID is common to both columns. So when customer ID is common to both columns, you join on customer ID. So you join on any column that is common to the both of them. So customer ID is common to both columns, and that's why we're joining on customer ID. You cannot join on say state because we don't have state in the other data frame. We don't have state in purchase info. So you join on customer ID. So customer ID, customer ID. So let's put this into a variable so that we'll be able to see, or we can just run it anyway. I just want, not like we want to use it for anything. So it just wants to check similarities in the data. So we're not performing any analysis on it. So let's just check what happens. So see, you can see that it has joined only the common values. So what I'm going to do now is I'm going to let us see this thing in the source. So let me do view purchase info. View view So I want to pass this to a variable so that I'll be able to call it. So I pass this to a variable so I'll be able to call it, and I'm going to rerun this so that it will store it into inner merge. So Control Enter, I rerun that. So I want to be able to view inner merge. So see, now I want to view purchase info. So see what purchase info is like. This is purchase info, right? So let me view personal info. This is personal info. Now look at purchase info and look at personal info. What is the common customer ID in purchase info and personal info? 2, 4, and 6. What is also common to this? 2, 4, and 6. So we have 2, 4, and 6 here, and we have 2, 4, and 6 here. That is why we have our inner dot merge showing us 2, 4, and 6 with the products that are corresponding to 2, 4, and 6, which is toaster, radio, and radio, and with the states that correspond to 2, 4, and 6, Alabama, and Ohio. So here you have it. So the normal buy function, buy with no specification, gives us the basic general merging, which is called the inner merging. So the inner merging takes the data that is common to data frame 1 and data frame 2. So we have 2 data frames, and it took the data that is common to data frame 1 and data frame 2 based on the column that is common to the both of them. Any questions, please? Before I move on, any questions? Let me go back to here so that you can see it properly.
I have a question,
If you
please.
don't have any question, so why don't you just tell me, go ahead. So I'll just continue.
Please, can you hear me? I have a
Any
question.
question?
Please, can anyone hear me?
I can hear you. We can hear you.
Can hear you. Can I get a go ahead from somebody? Anybody?
Yes, ma. If you can hear also.
Hello, Mike. You can hear.
So she can. Maybe someone should type it.
What did you say?
Adetoro has a question.
Okay, I'm listening to you.
Okay, ma. The inner dot merge, is it a
Yes.
function or you use
No,
it as a variable name?
It's a variable name.
So the I saw something. I was expecting to see an equals to sign, but I saw something like less than the hyphen.
Yeah. So in the last class, or in my own class, the one before Emmanuel's class, if you remember clearly, I told you that the less than hyphen sign is applicable to all forms of assignment. So you're assigning something to a variable. It's applicable in all forms, and that is why I like using it. So you can also use the equal to sign. If you look at your textbook, I think they use the equal to sign. Yes, they use equal to sign. Sorry, I'm just very used to using this sign. So you can use the equal to sign, and I can try to use equal to sign in this class too.
All right.
So any one of them would assign your variables. So inner.make is a variable. It's not a
Thank you
function.
very much. All right.
You're welcome. Any other question, please?
Sorry, ma.
Yeah.
How did you switch? How did you switch from your source to that table you brought up? Like,
Okay.
did you press in?
I use the view function. You mean to be able to view these ones, right?
Yes, exactly.
To be able to view these ones, I use the view function. I told us in the previous class too. So when you want to view your data properly, or you want to see it well, or you have a huge set of data, and you want to be able to see it clearly, more clearly, you use the view function. And the view function uses capitalization. So your V has to be in capital letters. If you use the small v, it wouldn't work. So view whatever data frame you want to view, and then it just comes up here. It comes up. Let me do it again so you see it. So um, okay. So that's it. Do you understand?
Yeah, I do. I do. So once you do that, you run it, then it creates
Are
a
you clear?
separate tab. Yes,
Who is
I'm
that?
clear. I'm saying
Are you clear?
yes. I'm saying when you write the view on the source,
Hello?
it's once you run the view, is it going to appear as a different tab on that?
Any other question? Okay, I'll just move on. But can you hear me?
We
Hello,
can
ma.
hear
We
you
can
very
hear
well.
you.
Yes, you can hear us.
Well, I think you.
Someone should please type we can hear her, please.
Okay, okay. All right. Thank
No,
you.
we can hear you, but you can't hear us
Okay.
clearly.
I don't know why I can't hear you clearly, but I can hear you now very clearly. Okay. So um let's move on. So we've been able to do the inner join. Now we want to perform an outer join. So because Stephen is trying to check for similarities between these two data sets, he's trying different kinds of joining. So we've done inner join and we want to do outer join. So we have two kinds of outer join. We have the left outer join and we have the right outer join. So the um, outer join doesn't match all the values. Outer join matches depending on the kind of specification you give to it. So for example, for the left outer join matches all the values that are common to, say, okay, say you have two data frames and you have data frame X and you have data frame Y. So it matches all the values that are in X and values that are in Y that are also in X. So that is what the left outer join does. The right does it the opposite way. So you have X on the left, Y on the right. The right outer join takes in all the values in Y and values that are common to X and Y. Left outer join takes in all the values in X and values that are common to X and Y. So that is what outer join does, and you're going to see it in this example. So this is the function you do. So let's assign this to a variable. Left outer merge, just naming it any variable, and you have merge, you want to merge X. So in outer joins, it's good to indicate what your X and Y values are, so that you are able to specifically tell R that you are merging on this particular data frame as X, and you're merging on this particular data frame as Y, and so on. So you have to specifically tell the R console that this is what you are merging on. Because if you do not indicate your X and Y values and you just ask it to merge on X, it wouldn't probably know what you are trying to say as X or Y. So if X is, let's take X as purchase info. So purchase info X, and Y is, I like putting a lot of spaces for clarity, but it's not compulsory. R doesn't work with spaces. So whether or not I put spaces, the code will run, to still run personal info as Y. Then you are merging on customer ID. Customer ID. And you're going to tell R that you are performing a left join. And the way to tell R you are performing a left join is using all.x. So this tells R that you are merging on purchase info, and X is what is on the left side of your merging. So you have two circles like this. I wish I could draw this. I don't know how I can draw this or show you, and it's not in our slides. Please just Google left join and see examples of what left join is, so you'll be able to understand what I'm saying. So you have X on this side, you have Y on this side. It's going to take everything in X and values that are common to X and Y. So all.x equal to true. I'll show you what to do now. True. So you're telling that merge everything and make it a left join. So that is what the all.x equal to true indicates. And so we are going to run this. Control enter. And I'm going to view this. Control V. Okay. So here. So look at this result very, very critically. What was my X value? My X value was, let me move this so that I don't have too many things on my source. So see this, my X value was purchase info, and this is what purchase info is, right? My personal info is 246. Purchase info is all of this. Now this purchase info was my X as indicated here, while personal info was my Y. And see what I did, I merged, I did a left join. So if you see my left join, you would see that I have all my X present, which is purchase info, while I only have these three present, because these three are common, are also in purchase info. So I only have these three present here. So you can see Alabama, Ohio, which is 246. So let me show you something so you understand what I'm saying better. Personal info. Let me go to personal info and do something. So let me add 8. Let me see. Okay, let me add 8. And let me tell it to repeat Ohio twice. And let me change this to personal info too. So I'm just giving us a scenario. This is a scenario so you understand better. So, and I want it to view personal info too. So here is personal info too. So I have 2468. Now I want to merge purchase info with personal info, with the new personal info. So I'm going to take, where's my merge command? My merge command, my left outer merge command. So I'm going to do another left outer merge command. Copy. And I'm going to paste this here, and I'm going to call this 2. And I want to personal info 2. I want to merge it on personal info 2. I just want to show us something. Personal info 2. And then I want to view this after. Left outer dot merge 2. So I'm going to run this. Run the something. Here. You see that it didn't add the 8. So why didn't it add the 8? Because I have 8 in personal info 2, right? I have 8 in personal info 2. Oops. Okay. I do want to reload. Remind me later. Okay. So I have 8 in personal info 2. But why did it come up in my left outer merge? This is because 8 is not common to purchase info. So it only takes in values that are common to. So let me quickly show you something. Let me show you. Let me just do this so that it will be easier. Left outer join. Okay. So this is left outer join. So this is left outer join. So this is a left table and this is a right table. It's taking everything in the left table and only those in the right table that are common to the left table. So I hope this is very clear. If you have any questions, please speak up. Please speak up if you have any questions on this particular thing, this particular left join that I just explained. If you have any questions, let me know because I'm moving on. So we're going to do the
so
right outer join ourselves, which is also similar to the left join. It's just the only thing you have different is all dot y equals 2. So you are joining on y, and the only difference will now be that this part is going to be the part painted yellow. Let me even just move it. This is the full join. So see, so everything in the right table with only those common to the left and right table. So that is what right outer join is about. It's the same thing. Right outer join, right join, same thing. So that is that. Then we have the full join that joins everything in both tables together, everything together. So that's the full join. So whether or not you are common, it joins them together. So that is about joining. If you have any questions, please let me know. Because I'm just going to move on. But if you have any questions, please stop me. Let me see if anyone has questions because I was not hearing some people that time. So
sorry, I put a question in the comments section.
Are you saying something, Harry?
Yes, ma'am. I was about asking. So I was saying what you explained about the left outer join, right outer join.
Yes.
So most definitely we can't use this concept when we have, say, an initial problem that is going to involve 3 columns or 4 columns.
You can't use it for a problem that will involve 4 columns.
3 or 4 columns. Yeah, that's what I'm asking.
Okay, you're asking. You can. In short, you will. Because you use joins on these examples that we're doing are very, very small compared to the kind of things you're going to do with R. So you're going to use it on tables with lots of columns, with about 4, 5, 6, 7, 8 columns and rows. So the only thing it does is it just takes columns that are common based on your joining column. So if say this one you had another column, you had another column, say country, it doesn't stop it. It just joins based on customer ID. So even if you had 10 columns here, whatever is present in the other column is what will be joined based on this customer ID. So the only concern or the only points to look at, the only place to focus on is the customer ID, which is the joining column. the column you are joining on, the common column to both data frames. So if you have 3, 4, 6 present in your order table, it will join columns rows 3, 4, 6 to this, not minding whatever is left in your table. That is just what it does. Do you understand? So
Yeah.
you don't yes, it doesn't consider the other columns. That is not its business. It just takes in all of the data that refers to those particular rows that are common. That is all it does. It doesn't really care about the other columns. That's why you need the key tables. You need those two tables to be present in both data frames. Any other question? So let's try to do the right join ourselves, and let's also try to do the full join ourselves. Full join is all equals true instead of the all dot x or all dot y that you normally do. So full join is all equals true instead of the all dot x. So yep. Then there's cross join where you do by equal to null. So you're doing x, y, but your by will be equal to null. So let me just do that and then we'll move to another thing. So merge, want to merge, okay, let's call it cross dot merge. And you're merging, what are you merging? X as purchase info. So you can decide to indicate your x and y's even when you are not doing left or right joins. It doesn't change anything. Y personal info and by equal to null. So you are not joining by anything. You're not joining by any column. Let's see what it does. View cross dot merge. Okay. So here, now let's look at this critically. Let me remove this. Let me remove this. Let me remove this. Let me remove this. And let's look at this too. So this is purchase info 1 to 6. Personal info 2, 4, and 6. Now look at what cross dot merge does. So it takes it takes the customer IDs of both columns. Now it's going to combine each of the customer ID on this with the customer ID on this. So you have a
Everybody,
very long.
not just
Okay, who is not on mute? Okay. All right. So that's what I was saying. It takes all the customer IDs in X and all the customer IDs in Y and combines them together. So we have 1 to 6 here. So it takes 1, 2, 3, 4, 5, 6, and then combines it with all the 2s from Y. It takes 1, 2, 3, 4, 5, 6, combines it with all the 4s from Y. It takes 1, 2, 3, 4, 5, 6, and combines it with all the 6 from Y. If you look at here, you have 1 to 6 here, and same with here. So that is what cross dot merge does. It combines every customer ID with the customer ID in the other data frame, and then and it adds the product and the states. The products for the first data frame and the states from the second data frame. So that's what cross dot merge does. So any question? We're moving to lab 2.
Please, my
Any
other
question?
question.
Okay, please go ahead.
Is there any criteria to selecting the X variable and the Y variable?
Criteria to selecting X? No. You determine what you want to join on. You determine what you need. You need a particular, say you need a particular data, and that is your priority. You just want to see the ones that are similar in the other data. Then you know that you are joining on X. So you can make if your X is Y and is Y you need. If you change X to Y and is Y you need, you do a right join. If it's X you need, you do a left join. You can switch X and Y. I can try to switch this. I can try to make X, Y, and Y, X here. It just depends on what exactly is my focus. If my focus is my data frame X, then I know that anything I'm doing, I'm going to join on data frame X. If my focus is data frame Y, anything I'm doing, I'm going to join on data frame Y. That's why you have different options. You have right join and you have left join, because your choice can change at any point in time. But what most programmers use is left join, and they use left join because it helps you get more focus, because you can easily say, okay, it is my first column in my merge statement that I'm majorly working with. I just want to see what is similar in the other one. So most of the time, the data frames you are more focused on are the ones that you make X, so that it's just easy for you. You don't have left join here, right join here, left join here, right join here, and so on. So you can arrange it however you like. You can make X, Y, Y, X, but then just know what you are focused on. That's all. So you have different kinds of joining that can suit whatever purpose you want to achieve. Do you understand?
Yes, ma'am.
Okay. So lab two, we want to, the analyst wants to see different views of the data to easily identify sizes of the t-shirts. So you want to see different views of the data and wants to be able to easily identify sizes on t-shirts. You can read the whole prompt, but I'll just summarize it. So this lab shows us the sequence of steps required to perform the task. So let's go to lab 2 on page 115. So we want to create a data frame. We want to create the data frame on page 109, and we're going to use the suggested solution on page 115 to do that. So this lab work is, you can see that it's helping us to point back to all those functions that we skipped that time. So it kind of helps you gather all your knowledge together in one place. But it's very good for you to go back and read your textbook, so yeah, you have more knowledge on these functions if you want to. So please, I'll still advise that you go back to your textbook to read, but then the lab helps you understand how these functions are used, and that is why our focus is majorly on the lab. And it also helps us cover all the functions that are in our textbook, that are also in the slides I showed you, but reading functions would not be necessary. I think practicalizing it would be much more better than reading. So let's create a data frame called employee data. So I'm going to leave some space. Employee. Okay. So employee data, and then employee data is, let me do this so that I can easily see what I'm doing. Employee data is so data.frame. The first column is the subject column, and then the subject column we have C to be Andrew. We have Andrew. We have Shenku. We have Rector.
David.
We have Michael. We have Michael. Yeah, do you have a question? We have Colchin. Yep, so this is what we have for the subject. For the time, we have 11. Okay, 11, 12, 15.
Sorry, Abisola, answer the question.
Yeah. Okay.
For
Go
this
ahead.
time, can that rep work?
And
What do you
what rep work? Yes, it
the
is real.
rep? Yeah.
Yes, yes,
This
it
time
is
I'm
real.
typing the 1111.
Yes, you can do that instead, like the way we did in the previous data frame. You can do that. Just input rep. Put rep in place of this rep 11 twice. You can do that, like what you did here. So it will work for you. 51, 66, 45, 56. Weight is 80, 90, 89, 56, 67, and height 12, 10, 15, 17, 20. So these are employee data, and okay, so this is employee data. So we have our employee data now, and we want to um, transpose it. So to transpose this employee data, you use the T function. So the T function helps you transpose. So when you do T employee data, it transposes your function, your data. So here, so you can see the result here. It's transposed. So instead of your subject time weights as columns, you now have them as rows, and then you have these names as columns. So T helps you to transform your data. So we are changing the view of our data. So that's what this lab work is about. And then we also want to reshape our data. So we want to create a new data set, and we want to put it in the way we want it to be. So let's do something to it. So we're going to, let's call it reshaped employee data. Reshaped employee data. So this is for transposing, and then we want to reshape our employee data. So the function we're going to be using is the reshape function. So the reshape function reshape. So reshape employee data, and okay, varying. I'll explain the command. Varying 3 to 5. V dot names equal to measurements. Measurements time var multi-dimension times equal to names employee data 3 to 5. So this helps you reshape your data to what you want it. ID var, I'll explain. ID var is measure ID, and 1 second, please. Okay, so let's run this and let's view the data. Okay, let me view the data. Let me put in the view command. View the shaped employee data. 1 second, please. Okay, so I'm back. Let's load this. Okay, so here we have, where is my command? Okay, so we want to reshape employee data varying 3 to 5. Then we also want to where is employee data? I want to see our employee data. Okay, varying 3 to 5. Rector Emmanuel Colchin. Okay, there's something missing here. Okay, let me move to this first. So V names, we created a measurements column, and then we also have okay, we created a measurements column. We created a measure ID column for the 5 data sets, and for the 5 rows. Another thing we did was each of the 1 to 5 rows, because if you see here, we have 1 to 5. We have rows 1 to 5. And you can see here we have, I'm trying to explain it the best way possible. We have dimension, age, weight, and height. And we don't want this column, we don't want this format, we want it in a long format. This is called the wide format. So we want our data in the long format. So we merged the data rows, the row numbers, with the column values. So we now have 1 to time, 1 to age, 1 to weight, 1 to height, and so on. 2 to subject, 2 to time, 2 to age, 2 to weight, 2 to height, 3 to each of them, 4 and 5. So first of all, that's what this did to each of them, 1 to 5, weight and height. And we have just age, weight, and height here. Age, weight, and height here, because we wanted just 3 to 5. So now come back to our reshape function. So we varied 3 to 5, and if you see here, we only have 3 to 5. So age, weight, and height. So that 3 to 5 is telling us we are varying from the 3rd to the 5th column. So that is where we have our row columns varying by the 3rd to the 5th columns, which are age, weight, and height. Let me scroll down for you to see age, weight, and height here. So the age, weight, and height, they are represented as dimension here. And if you see the code, we also said time var should be dimension. So the dimension would carry our varying names, and our varying rows, which is 3 to 5, and that is what is represented here: age, weight, and height. Now, another thing I want to look at is the employee data 3 to 5. Okay, times. So the times are the times we have the times as the names of the employee data from 3 to 5. So the time, this is the time, and we are only taking the ones from 3 to 5. So here we have 11. For example, 1 to age is 11. Let me just pick some. 1 to age is 11. 2 to age is 11. 5 to age is 15. So if you come here, 1 to age, 11. 2 to age is 11. 5 to age is 15. 5 to age. The time here is 15. So just link them together. And okay, so basically what reshape does for us is it changes your wide format of data into a long format. Now it combines your rows and your columns together. There are some times that, okay, so this is useful for changing the view of your data. So say you don't like, maybe you have a very long, maybe you have so many columns in your data set, and you don't like how long the columns are. You don't want the columns to be so long. You prefer to have a longer table which would have more rows than to have a very wide table that has columns, because in practice wide tables are not useful for analysis. They are not proper for analysis. So you convert a table to a long table. That is what the reshape does for us. So you can decide to exclude some of these from your table. For example, you can exclude the time var, the dimension, and not have the dimensions repeating themselves here. You can do that. And then this also added an ID, 1 to 5. You can exclude this too. Since we already have it here, you can exclude the dimension too. So it's still up to you. It depends on what you want. So, and then we have the measurement. Now, what we did with the measurement was we said the variable names should be called the measurement. So if I show you 1 to age, the measurement is 34, and say, let's say 4 to age, the measurement is 45. If I come to employee data, 1 to age is 34, 4 to age is 45. So what it just did is it elongated the data instead of leaving the table as being wide. And then it's going to be very useful in practice. Say you have a table that has 20 columns. It wouldn't be easy for you to perform analysis on it. But when you have it like this, and you have maybe 3 columns and it's very long, it's still easier to perform analysis on a long table than on a wide table. So this just comprises of a lot of things that you can use. You don't have to use everything in your reshaping, but these are the different arguments that you can make use of in reshaping your data. Please, if you have any questions on this, let me know. I'm sure this was a bit confusing, but I'm sure you were able to get something. So if you have any question on this, let me know. You can take out some arguments. You don't have to use all the arguments in the reshape function, but the reshape function takes a lot of arguments depending on what you want to do to your data. Any question? Let me see. Okay, if I can't hear you, please raise up your hand. Okay, please go ahead.
Yeah, sorry. I don't know. I don't understand the syntax of
Reshape function.
function, especially the three 3 to
3
5.
to 5.
Yeah.
Which
Yeah.
other part don't you understand?
The other argument basically still seeming is.
You don't understand everything. Is that what you're saying?
I understand that the first argument is the table you want to reshape. Then, well,
varying 3 to 5. Now, varying 3 to 5. 3, third column to the 5th column, age to height. Do you understand that one?
Okay, yes, that's fine.
Yes, that's fine. So that's why you have your mapping to age, weight, and height alone. If you see here, do you understand that one?
Okay.
Okay. And then another thing here is v.names, variable.names, which is measurement. So this measurement took in all these values. So for example, if you look at this, the best thing to do is to look at the reshaped data and to look at the argument you passed in. So sometimes you use your results to understand the function you performed, or the whatever analysis you performed on your data. So look at 2.age and to measurement, you have 51, right? Now come to this data. So 2 to age is 51. Can you see it?
Yeah.
Okay, let's see something.
Yes.
4 to weight is 56, right? 4 to weight is 56. Now come here. 4 to weight is 56. Do you understand?
Yes.
Okay. So that's just basically what it does. It's just elongating your data.
Times equals names.
Okay, so let's go to the next one. Times equals names employee data 3 to 5. So now let's see what times is. So time is giving us 11, 11, 12, 12, and so on. Now see something. Let's look at 2 to wait, giving us 11. Now come here. 2 to wait gives us 11. So 2 to wait. You look at your x and your y, but then we are considering what here? Time. So that's why it's picking 11. If you check 2 to height, you also have 11 because it's picking time. If you check 3 to age, you also have 12. Do you understand? Just check your x and your y and look at the dimension that is being considered. So 2 to weight, we want time under 2 to weight, it's 11. 2 to height will also give us the same thing under time, 11. So let's check 2 to height. 2 to height, 11. Do you understand?
Okay. And I don't understand though. What? Because
Okay.
we didn't reshape the time column now. We didn't select time column as what we are reshaping.
You didn't select time column.
Yes, the 3 to 5 you selected. Was time part of it or?
No, you are saying the times column is equal to what? You are checking the names of the employee data for the times column. That's what is happening here. This is a column. All these things are columns. So time, the times column, you have the time column, right?
Yes.
This is your time column. Yes, and you're telling it that it should give you the name of employee data from 3 to 5. So I've told you what 3 to 5 is. 3 to 5 is this, age to height, right? And then you want the names of employee data for 3 to 5. So we have 3 to 5 already here, which is age, weight, and height.
Mm-hmm.
Okay, so you are checking this with respect to what the time is. So you want to check for time here in your employee data. And 2 to height would give you what time is. Okay, I don't know how else I should explain this. Who understands? Probably the person will be able to explain it better. Anybody?
Sorry, okay, no problem.
Okay, you know what?
Try.
I'll come back to this to explain it better because of time.
Sorry, one more question.
Anybody? Okay. Okay.
I wanted to know, I was trying, okay, when I wanted to input my table the height
Yeah.
of the employee, I just tried to try decimal values and it gave an error. So is it that you can't pass decimal values to, or is there some form of syntax you have to
You mean
use
for
to
this one?
pass? Yeah, for creating the table itself, not the when I
Okay.
wanted to create the
Did you?
employee table, the height.
Okay. Did you add? Is everything a decimal value?
Yes,
Everything. Did you make everything decimal values or only one?
all of them.
You made all of them decimal values,
Yes.
and it gave you an error.
Yes, it said unexpected numeric constants.
Okay. Let's look at that. I don't want to change this. Let's go to the. So maybe you have to change the format of the data. I think that's probably the issue with it. But let me just see. unexpected comma in each. Which comma? Oh, okay, I understand. Okay, I didn't get any error.
No
Is this what
error.
you are saying? Is this what you are saying?
Yes, exactly. Something like that.
Did you change everything? Because when you have a vector, all of them must be of the same data type. So are they all of the same data type?
Yes, everything was 1 point something.
Okay, please check well again because I just did it now. So check well
Okay,
again.
no problem.
For
I'll
this
just check.
one,
Right.
if it still confuses anybody, maybe we'll take our time to explain it later. But let's just move to another thing.
I
Our
have
time
a
is fast.
question.
Yes, you said what?
I have two questions.
Okay,
The
go
question is
ahead.
that if I don't want to use dimension, like for the column name, like and measurement, can I use another column name like to name my column?
Yes, you can use another thing.
Okay. Number two is that I can also use, instead of using time as my point of reference, I can use age as point of reference also, right?
You can use what?
Age as point of reference. You use time as point of reference for this one now. I can also use
Okay.
age as point of reference, right?
Have you tried it?
No, not yet actually.
Okay, can you try it?
Yeah, I will do that.
Okay. So if you try it and you try it and then you see what it does, then we would know. But if I keep trying every suggestion, I might not leave here today. So just try it and let me know. Let me know what you got. So if there's any problem, then you can let me know. Um, okay. So let's move on. So I'm moving to subsetting subsetting of variables. And in our lab we are asked to, that is lab 3. Okay, so there's this data set and we want to subset the data set. So we want to create subsets of this data set. So let's go to the suggested solution on page 115. So for this particular reshaping, I would like you guys to just try removing some arguments, putting some arguments back, and seeing what it does, what it gives you. So like I've told us before, to learn these kind of things, you can't learn everything in the classroom. You have to go back and try removing some things or putting some things and see what it gives you. Then from results that you get, you can now determine and say, okay, I think this thing, when I don't put it here, I can put something else, or I can put something else, and so on and so forth. So that's the best thing to do. You can't learn every thing in the class. So if I wanted to start checking each of them one after the other, I might not live here today. So let's just try. The reason for you being taught is to give you the background knowledge. Then when you go to your when you have your private time, you can try them and try to remove some arguments and see what it gives you. So I think that's the best way to learn. So let's go to lab 3. The solution for lab 3 is on page 117. So let's check I didn't even check our working directory. So let's check our working directory. We want to subset data. Oh, I thought I was in the console. So this is our working directory, and we want to set our working directory to what? Okay, let's leave it. Let's just see. Okay, this is our working directory. We are looking for a data set which is books.csv. So let me see if the data set is here. It's not here. Okay, it's in home/Hadoop. So let's set our working directory to home/Hadoop if we would find it there. Home/Hadoop. slash Hadoop, and yeah. Okay, let me just check it from here. This shows only objects, right? So let's oh, am I doing R? Oh god, escape. Present working directory. Okay, let me just close this. I typed in the wrong command. Okay. PWD home/HD user. So we are an HD user. Let's set it to Hadoop. Home/Hadoop. I hope the data is here. Okay. Then let's check for the files available. Okay, we have data set. Let's check for the sub files. So let's see data sets. Okay, now this is a lot. Let's navigate to data sets. Once we're looking for the books data, books.csv data. So we're going to data sets. Oh, it's not available. There's no there. Oh, okay. No slash here. Okay, so now we're in data set. So let's check for the files available in data set. Do we have books here? Yes, thank you. So this is books.csv, and that's the data set that is used on page 117. So I wanted to confirm that this is available here. So we have books.csv available on our Hadoop environment, on our Hadoop folder under data sets. So let's read our files from data sets. So let's read it into books. So books read, so you use read.csv to read CSV files. And then we are on home/Hadoop. We're not yet on dataset. So you can either navigate to home/Hadoop/dataset, or if you don't want to leave home/Hadoop, you can just put in dataset as a folder, then slash the name of the dataset you need to get. So CSV. And then I'm going to tell it to add the header. So header equals T, which is true. So we've taken in the data set to, we cannot open the file. Books, no book. Oh, I've started working on, I started working on the console. Okay, let me come back here. Books, read.csv, data sets. Oh, time is gone. Okay, books, CSV, and header is true. So yeah. So let's view books. Yeah, so this is our books data. These are our books data, book name, this and this. Any questions before I continue? Okay, so our time is fast spent. You might have to perform the remaining 2 lab exercises on your own. I'll finish lab 3, and please go and do lab 4 and 5 on your own and come back to ask me questions. So if you have problems with doing lab 4 and 5, please come back to ask me questions. I would love to take questions on lab 4 and 5, but I was able to do, I'll complete lab 3, so that means I will do lab 1, 2 and 3. Then you have to go and check up lab 4 and 5, do it on your own as an assignment, and come back to ask me questions. So I want questions, so I will expect questions knowing that you've done lab 4 and 5. So let me complete lab 3. Sorry for taking your time. So this is our books. We have our books data, and we want to subset our books data. So when you want to subset, you can do, it's usually row by column. So if I want to subset by row 3, column 4. Why am I here, by the way? I'm supposed to be here. Books, row 3, comma 4. Okay. So let's see. Let me cancel this one. This. So books, row 3, comma 4. Oh, this is empty. So this is empty, so we don't have anything here. So let's do row 4, comma 5, comma 4, or something else. So let's do comma 3. NOLA. So let's go here. Row 3, comma 3. We have NOLA. So it's showing us all the others available on this column, all the other levels, but it brought out row 3 versus column 3, which is NOLA. So if I wanted to subset by, say, I want it to give me all the rows. I'm going to leave this space as empty because I want to give me all the rows. Then I want to have columns 2 to 4. So I would put it in form of a vector, columns 2 to 4. But I want all the rows. So I'm going to have this. So you can see I have all the rows, which is rows 1 to 9, as indicated here. Oh God, why am I reloading? So I have all the rows as indicated here, which is rows 1 to 9. Then I have only 2 to 4. So it took out this. So this is 1, 2, 3, 4. I have 2 to 4, which is what is available here. So that's about subsetting data sets. Then I have 3 ways to subset my data. If I want to subset my data, I could do it in 3 ways. I could do the single bracket, I could do the double bracket, and I could do the $sign. So I can also do something. Let me get a column name here. I have AUTHFN here. So I can do this. Books $AUTHFN. So it gives me in form of a vector the column AUTHFN, which you can see here. So that is what the $sign does. So that is subsetting with the $sign. And then I can also say I want only rows 3 to I want only rows 3 to 6. And I want all the columns. So I want rows 3 to 6 and I want all the columns. So it's going to give me rows 3 to 6 and all the columns. So when I'm indicating my columns, I put it in the form of a vector. But when I'm indicating my rows, I could just do from what range to what range. So please let's take note of that. That's for subsetting rows. So I can also do a subset in form of logical operations. I want to see if something is greater than something or something is less than something. I want it to give me values in that range. So say I want to subset books. So I'm going to use the subset function. So I want to subset books, and I want it to subset for me where AUTHID is greater than 1010. So it's going to give me where AUTHID is greater than 1010, as seen here. So that is using the subset command. So this is how to subset with logical operations. And I could also do other types like equal to and so on. This subsetting with logical operations. So say equal to. So see, I have where AUTHID is. Oh, sorry. Logical. When you are doing when you are trying to check equal to, use the double equal sign. So equal to. So you see, I have just this. So the double equal sign. Please take note of that. And I could also subset in this format. I could also do this. I could also say subset of books where AUTHID. We'll soon round up the class. AUTHID in. So I want to see AUTHID in C from 1008 to 1010. So see, I'm trying to subset from 1008 to 1010, and I have to put this in form of a vector. When I'm using the whenever you're using the in command to check to check logical operations, you want to check if AUTHID. You want to check for books where AUTHID is between this and this. You have to put it in form of a vector and then use the in command, and the in command has 2 percentages by the side. So 1008 to 1010. I have it here, and it brought out data for AUTHID from 1008 to 1010 as indicated here. So that's another way to use the subset function. And you could also, okay, I've also taught us how to remove variables. So if you have this, say you have, okay, let's do this. If you want to remove all variables, well, let's not remove all variables, but I remember I taught us that RM is for removing objects. So there's an object you created and you want to remove it, use the RM command, but I don't want us to remove anything here. So we're just going to save this for today, and you would do lab 4 and 5 on your own. Then please try to work on it, try to do it. It's just about 2 pages, about 4 pages. So do lab 4 and 5, and please come back to ask me questions next week. So if you have any questions, I'll be here to attend to them. So thank you very much, everyone. And if you have any question, please speak out, let me know, so that I'll just quickly answer your question and we'll round up the class. We are 12 minutes ahead of 12 o'clock. Any questions? Or you want to save your questions for next week?
Yes. Next week, ma.
What did you say?
I say yes, next week, ma.
Okay, next week. Okay, so please go over everything. You might still see some gray areas. There might still be some places you didn't understand properly. So go to your manual. Try to go over everything we've done today. Okay, what I'm going to do is maybe I'll find a way to send this to you. So let me just save it. if Emmanuel would be able to save this and send this to you. Let me save it as, what's today's date? 27 July. So you'll be able to go through it on your own. I'm saving it in graduate training. So yeah. Okay. So I would see if Emmanuel can send this to you. Or let me confirm. Would you like Emmanuel to send this to you? What I did today, so that you can go through it and also go through your manual alongside.
Yes.
Okay. Can another person answer? Are other people here? Are you the only one? Who else is here? Please let me know that there's somebody else here.
I'm here also.
Okay, okay. So Emmanuel will send this to you. Go through your manual. If you have any questions, please let me know next week. Thank you, everyone. Bye.
Thank you, ma'am.
Thank you,
Bye,
ma'am.
ma'am. Thank you
Thank
so
you, ma'am. Bye.
Enjoy the rest of your day.
Thank you, ma'am.
Thank you, ma'am.
Bye, guys.